Bismillahirrahmanirrahim. My name is Mehreen and I am going to present on the topic of geotech. What is geotech? Geotech is the type of civil engineering that is concerned with the rocks and soil. It is the study of the behavior of soil under the influence of loading forces and soil water interactions. How soil form. More or less solid rock is a relatively thick layer. Material can vary from submicroscopic particles to huge boulders. Weathering is also effect on the formation of rock. Weathering, which usually result from atmospheric process, alter the composition and the structure of rocks by chemical and physical means. Physical and mechanical weathering causes disintegration of the rock into smaller particle size. Physical weathering include freezing, temperature changes, corrosion, and the activities of plant and animal, including man. Chemical weathering also affect the rocks formation. There is chemical weathering is the decomposition of decompose. Chemical weathering decomposes the minerals in the rock by oxidation, reduction, carbonation, and other chemical processes. In short, soil are the product of weathering of rock. They are often highly variable, even a few millimeters. They are heterogeneous rather than homogeneous. Particle shape. Refinements are rarely warranted, only a qualitative shape determination is usually made as part of the visual classification of soil. Coarse grained soil are commonly classified according to the shape. A distinction can also be made between particles that are bulky and those which are needle-like or flaky. Mica flakes are an excellent example of latter, and Ottawa sand is an example of former. The bulky grains hardly compress at all, when a very small, very loose state, even when in a very loose state. But the mica flakes will compress even under small pressure, up to about one half of their original volume. Clay minerals. Clay minerals are very tiny crystalline substances evolved primarily from chemical weathering of certain rock-forming minerals. Chemically, they are hydrous aluminosilicates plus other metallic points. All clay materials are very small and they can only be seen with an electron microscopes. The individual crystals look like tiny plates or flakes, and from X-ray diffraction study, scientists have determined that these flakes consist of many crystal sheets which have a repeating atomic structure. In fact, there are only two fundamental crystal sheets, the tetrahedral or silica and the octahedral or alumina sheets. The particular way in which the sheets are stacked together with different mounting and different metallic on it in the crystal lattice constitute the different clay minerals. The tetrahedral sheet is basically a combination of silica tetrahedral units which consist of four oxygen atoms at the corners surrounding a single silicon atom. The oxygen atom at the base of each tetrahedron are combined to form a sheet structure. The oxygen at the bases of each tetrahedron are in one plane and the unjoined oxygen corners all point in the same direction. The top view of silica sheet showing how the oxygen atom at the base of each tetrahedron belong to two tetrahedrons and how adjacent silicon atom are bounded. Capillarity. Capillarity arises from a fluid property known as surface tension, which is a phenomenon that occurs at the interface between different materials. For soil, it occurs between surface of water, mineral grain, and air. Fundamentally, surface tension results from differences in force of attraction between molecules of the minerals at the interface. The phenomenon of capillarity may be demonstrated in many ways. Placing the end of a dry towel in tub of water will eventually result in a saturated towel. To illustrate the effect of capillarity in soil, we can use the small diameter glass tube to represent the soil grain. Capillarity tubes demonstrate that the adhesive forces between the glass wall and water causes the water to rise in the tube between the glass and the tube wall. The height of rise is inversely proportional to the diameter of the tubing. The smaller the inside diameter of the tube, the greater the height of capillary rise. Frost action. Anytime the air temperature falls below freezing, especially for more than a few days, it is possible the pore water in soils to freeze. Frost action in soil can have several important engineering consequences. First, the soil can immediately increase about 10% just due to the volumetric extension of water upon freezing. A second, but significantly more important factor is the formation of ice crystal and lenses in the soil. These lenses can even grow to several centimeters in thickness and cause heavy and damage to light surface structures such as small building and highway pavement if soil simply froze and expanded uniformly structure would even be displaced since ice is significantly stronger than the slide structure. However, just as with swelling and shrinking soil, the volume change is usually uneven. Differential movement occur and that is what causes structural damage.